Hello and welcome back to the channel. My name is David Young and I'm a computer science student at Concordia University, Chicago. And this is episode 4 of my series on software engineering basics. We're going to be talking today about real-world software costs. What does the budget of a real software engineering project look like? We've already talked about an introduction to software engineering, the difference between software engineering and software programming, and some real-world instantiations of software engineering principles in software processes and methodologies. Today we're going to be talking about the real-world costs of software engineering projects, and then we'll wrap up our series by talking about challenges and professional issues faced by software engineers. Before we begin, I'd like to ask you to like, subscribe, and share this video so that more people can learn about software engineering. Thank you. So let's take some time to break down software costs in the real world and what the budget of a software engineering project depends upon. So it should be noted that estimates are often murky when it comes to software engineering. So especially with models that de-emphasize big upfront planning, for instance, the agile model, it's going to be really hard to pin down the extent of a software engineering project and the budget that you are going to actually spend on that project. And so often what will happen is that the estimate determines the budget rather than the actual cost of the software determining the estimate. The estimate kind of is self-fulfilling for the price of the project. But there are some key factors that are going to influence the price, the cost of a software project. For instance, the project scope and complexity. Bigger projects are going to cost more, obviously. And it's important to remember that more code introduces even more possibilities for bugs. Complexity doesn't just grow linearly with scope, it grows exponentially. And so as you pile more and more software on top, the likelihood of bugs increases and new bugs are possible. And so your project scope, as that gets bigger, your complexity is going to get way bigger, and that's going to drive up the cost. The factors of software pricing also include team size and competence. So how many people are you going to have working on this project, and how good is this team? Are they experts in the programming language that you're going to be working in? Are they experts in using your tool chain, or are they relatively inexperienced? Are going to need to do a lot of training. Speaking of a tool chain, how much are your development tools costing? Are you spending a lot of money on, for instance, Jira project management software? Or are you using some other way to manage your projects? That's going to impact the overall price of your project. And as we talked about last time, the project methodology is going to impact the price. So there are different methodologies that have different requirements. For instance, DevOps requires a lot of tools and some training. So that's going to impact how much the overall price of your project, if you're going to need to train your team on that. One constant thing, though, is that maintenance often accounts for over 60% of the total software costs. We alluded to this earlier, but maintenance and maintaining a project for the long term, once it's been deployed to customers and bugs are being found and new hardware is coming out, is going to be super expensive, especially as the lifespan of a project increases. And so that it's important not to forget that when you're budgeting for your project, that keeping this going long term is not cheap. Let's look at the relative cost of fixing software faults. So let's assume that you're making an error relatively early on in your project. So you're making an error towards the start when you're planning out your project. Well, if you catch that error early, you can, like during the requirements gathering stage, it's going to take one unit of effort. So this is all relative. It's going to take 1 unit of effort to correct that. As you move through the process, you'll see that correcting that error is going to take longer and longer and take more and more resources until, if you're fixing an error that you've coded in and developed with and tested, and you need to rewrite a lot of code, in the maintenance stage, that's going to cost 200 times what it would have costed if you had fixed it early on. And so this is why it's so important to be attentive and to think things through. And it can be really, really expensive if you leave a mistake, because that becomes entrenched and concretized in your project and in your code, and it's going to cost a lot more to fix it during the maintenance phase when you already have a lot of code built around it and there are a lot of dependencies than it's going to cost to fix it if you catch it early on. So why is maintenance so expensive in software? Well, for one, it's what we just talked about. Little problems turn into big problems as more code is built around them. So you can imagine that if you have an error that you didn't catch and you've built 10,000 lines of code that rely on a piece of software that is errant, that has an issue in it, well, it's going to cost you a lot to rewrite all of that code. It was a relatively little problem, just maybe a logic error. It's going to be really expensive to fix it once everything's been codified and sort of set into stone. Maintenance time may also be several times longer than the development time. We talked a little bit before about Microsoft Word and how it's been around for 42 years. Obviously, the time that it's been maintained and evolved has been a lot longer than the initial time that was invested in just getting it to work. There's been ongoing support and evolution of that product throughout its lifespan. And so you can see how, in terms of the budget for Microsoft Word, that maintenance has taken up such a big portion because it's been ongoing for 42 years. New technology and hardware may also cause problems with your old software, and so maintenance needs to address constantly changing technology and new hardware that's going to not run your code, or it's going to make your code inefficient. And so this new technology and this perpetual change is going to require perpetual adjustments to code, and that's going to add up and raise your maintenance costs. It's also true that working with other developers' code is hard. And so maintenance teams are often working with the code that was written years ago. Think about for Microsoft Word, that was written by people who are not on that maintenance team. Because software is so hard to conceptualize and just take a look at and fully understand, that's why robust documentation is so important when you're dealing with maintenance, because it allows you to gain a glimpse into the thought process and what the code is trying to accomplish, and then address issues based on that more complete understanding of what's going on. So that helps, if you're not the person who wrote the code, that will nevertheless help you to address that issue. Furthermore, pairwise programming can also minimize costs. This is a practice wherein instead of one developer working on one area of code, like a function, for instance, programmers work in teams of two. And that way you have two people who understand the code, not just the one. And that's going to save you some of the headache of trying to look through other developers' code and figure out what's going on. Let's look at some case studies of project budget and budget factors in projects. We've talked about Facebook already in this series, but it was begun in 2004 by 4 college students, and now it's the largest social media network in the world. And so you can imagine that the development cost initially for Facebook was relatively small. It was kind of a passion project for these college students. It was something that they were interested in. But now the Meta Corporation spends $95 billion a year, and much of that is aimed and geared at maintaining and keeping up Facebook, maintaining the infrastructure, but also the software, addressing bugs, etc. And so you can see how the maintenance costs have far exceeded what it took to initially develop Facebook across the 20 years of Facebook's existence. And so this is a case in which the maintenance costs have vastly outweighed the development costs. Another case study that we're going to look at is the case of Knight Capital Group. In 2012, Knight Capital Group was the largest trader in U.S. equities on the New York Stock Exchange. So it was a gigantic company. But they left a bug in their code that bought $7 billion worth of stocks in one morning that wasn't checked by anyone. The software just bought it itself. And those trades were unable to be reversed which led to the Knight Capital Group going under and getting bought out in very unfavorable terms by a competitor. So this demonstrates the fact that we were alluding to with the chart about how fixing problems in the maintenance phase is a lot more expensive than fixing them earlier on in the process, because a lot of times errors are irreversible. If you, for instance, don't keep your users' data secure, or in this case, bug causes your software to go rogue, it's going to cost a lot more to fix after it happens than it would have if you had caught it and paid attention and tested well earlier on in the process. So that shows how not taking the stages seriously and not catching things early can really upset your budget by adding a lot of maintenance costs. And finally, we use the case study of the Apollo 11 mission. So during the Apollo 11 mission, the computer on board, right before they landed on the moon, the computer became overloaded and it wasn't able to maintain all of the functions that it was supposed to be doing. It just didn't have enough processing power. But thankfully, the lead designer of the code that was running on Apollo 11, Margaret Hamilton, she ensured that essential functions would take priority in the case of a computer overload. So she had accounted for this. And this enabled, rather than having to cancel the mission and come home, this enabled them to safely land on the moon. And it shows, this is the kind of the counterexample of the last case study. Careful code writing, good design. Even before this problem had been encountered, because she paid attention, it saved a multi-million-dollar project from having to be canceled and attempted again. So this is why writing good code is important and how it can save lots of money in maintenance costs. A lot of times, because maintenance can be so expensive, and really all the phases of development can be so expensive, companies undergo cost-cutting measures. One way that they might do this is cloud migration. So rather than investing in physical infrastructure and local infrastructure, for instance, a bunch of server racks or computers, companies may offload that to the cloud and do some cloud computing, or have their data stored in a server elsewhere that's not on their premises. And this allows companies to minimize their upfront investment in resources that, one, they may need to scale later, and so they have to invest more in. It allows them to access resources at a large scale, but only pay for what they need at a certain time. And so it can save money by minimizing the infrastructure investment and relying on extant infrastructure that can scale with a growing or shrinking user base without companies having to pay for things they're not going to use or have to continually be upgrading their infrastructure. Outsourcing is similar to cloud migration. So rather than, for instance, if you have a part of your application that needs to be developed, or if your application is needing to be maintained, you can use a company that can do it at a lower price than it might take to pay your people to do it, and that can help keep your project on track and on time. And particularly if you're outsourcing the maintenance of your project, you can save money because you can outsource to an IT company, for instance, who can keep watch over your project as needed, but you're not paying people to exclusively watch over the project and maintain it if that's not needed. Another way that companies are going to attempt to cut costs is through open source adoption. So rather than using proprietary products like Microsoft Word, they might use something like LibreOffice or things like this, code that is open source. And this is going to save money in the price of development tools, and it's going to mean that these companies can spend those funds elsewhere in paying people rather than on licensing software, when open source solutions can do the job. Automation, we talked about this when we talked about DevOps and CI/CD, but automation decreases the amount of human labor that needs to be done, and thus can be a cost-cutting measure. And similarly, AI-driven testing can help minimize some of the work that's done on the testing end, and therefore diminish the cost of your product, especially though as you are testing with these automated methods. You need to be extraordinarily careful, and we'll talk about that in the final episode of this series. Thank you so much for watching. Next time, we're going to talk about challenges and professional issues that are faced by software engineers. Please leave any questions that you have in the comments, and don't forget to like, share, and subscribe. Thank you.